Hello, this is an introductory video for PioSolver-preflop, which is Holdem preflop solver. It solves heads-up spots in Holdem. So first, as you can see, the interface is very familiar. This is our Pio viewer, and you have to make sure you are connected to the preflop version. And here it says PioSolver Edge 1.7 preflop, which is a version from today. You will get that engine with your Edge activation, and the way to connect is choose solver here and then connect, and then choose your new engine, which I already did. So new stuff here is in full preflop tab, and here we have preflop tree builder. So traditionally we have some preflop templates prepared by me. Those are trees you can start from to see how to correctly build a tree. And what I'm going to do is go over those things a bit, and then we are going to build one from scratch. So you see how the process looks like. So what we have here? First, let's see 6 max small blind against big blind. This is a traditional tree which contains all the actions, include folds, raise, and etc. So first we have effective stacks, which are 1000 because this is 5-10 no limit. OOP player mana in the pot. Those here are for blind amounts. And if you want OOP being on a small blind like in 6 max, you put 5 here and 10 here. And if you would like to make it heads up, then you would make it like this, right? For now, let's stick to our configuration. There's also extra dead mana in the pot, and this is for antis or small blind who are defaulted, like in button against big blind spot. So it doesn't concern us as of right now, but it is something you can use for those spots. And there we have this tree, and let's read it. There's raise to 30 or fold. Those are options for small blind. After that, big blind can raise to 90, can call, and can fold. After raise, we have a 4-bet to 210, a call and a fold. Here's a shove, call, fold, and then after the shove, we can call and fold again. And as you can see, some of those nodes are in green, and the green means that this is where flops are dealt. You can see that this call is not in green because this is an all-in already, so there is no need to go to the flop. But here we are going to the flop, and as you can see, when I click one of those nodes, the familiar form appear on the right, and this form here is for our preflop betting structure. So we can choose what the betting structure is for every separate preflop exit. So as those are pre-prepared templates, I will put stuff in here. So this is a single raised spot, like we raise and then there is a call. You can see that I've chosen sizing of 75% on every street and raise to 3x. This is a very simplistic configuration. Oh, actually, I see that I should enable OOP bet here because OOP is the preflop aggressor in this spot. Let me save that. Yes, and I have chosen a very simplistic betting structure. In general, what you want for those preflop configurations are very simple configurations which are small, so we can fit more flops in, right? And in practice, it doesn't really matter how detailed that is, because all we need is our very good approximation of EV. And if you put like 2 sizes here and 2 sizes here and whatever, it really doesn't matter that much for EV, and it's only going to take more space, and that's something you definitely don't want this solver, because yeah, no limit Holdem from preflop is a huge game, and we are not able to solve all of it yet on a home computer, so we really want to cut the tree as much as possible. You can see I went a bit wild on it, putting cap of 3. That means the 3-bet is always all in, and I have found out that this doesn't change EV that much either. So this is a safe settings and which allows you to build like more trees, more flops. So this is a very standard like configuration here. You have a 3-bet pot, and a 3-better is in position in this example because the big blind is in position 6 max. So yeah, we have a standard bet sizing for this. Again, I can put cap 3, although this here shouldn't matter. And there is a 4-bet pot as well, and the bets are smaller here, right? And again, it's important to include OOP bet here because OOP is a preflop aggressor, so he is going to they're going to bet a lot. So after we fill those in or load them from pre-prepared configurations, we can start building a tree, and this is interesting. We first need to choose how many flops we want on our, for our post-flop trees. So I prepared some subsets. There are many of them, as you can see, and you will find them in subsets, flop subsets folder in your distribution after you update the preflop solver. So what we have here are directories sorted by, named by amount of flops, and in every one of them you have 2 subsets to choose from. So they are carefully prepared to be very good approximation of the game, and obviously you would like to build as big a tree as you can on your computer, but RAM is a big limitation here. So what we are going to do is we first are going to build it on 10, let's say 10 flop subset. So we choose one of them, like here, and then we go to our task manager, right? It's here. As you can see, I don't have almost anything running here, or only this recording software and some minor stuff. So when I build a tree, we can see that it's building, and it taking a lot of memory. I have 32 gigabytes of memory on this computer, so this is my limitation here. So I can choose. I can see that when I build on 10 flops, it took 8 gigabytes, right? So I have 32. Maybe I can use like 30 or 28. So I could build this tree using like 35 flops, maybe, right? You just multiply and see. There are no memory checks, so if you go wild and select like 100 flops, it's going to, it's going to freeze your computer because the operating system is going to work to use the swap file, which is very, very slow. And if that happens to you, then yeah, you either wait or you kill that process or you restart your computer because yeah, it's not going to be pleasant. So be careful. Okay, so we have built this tree, and we can browse it. You can browse it like traditional tree, like the same way we can do post-flop, right? So we can verify that this is a tree we want, right? There's raise to 30 or fold, then there's a 3-bet call or fold, then there's 4-bet call and fold, and there is a show of call and fold. And we can go to post-flop as well. As you can see, this is not ready yet, and this doesn't display correctly. Like we have 1, 2, 3, 4, 5, 6, 7, 8, 9 flops, so one got lost, and they only contain like last card. So that doesn't work correctly yet, but it does work enough. You can go there and browse those flops as well, right? And so show strategy, right? So this is like only sanity check for now. You can go to those flops and browse. Of course, the solver has the whole tree underneath, and we are going to add the full tree browsing very soon, like in coming days. So you could go to those flops, like seeing all the cards instead of that. So anyway, you can see that this is a correct tree. And then to run this tree, you go to tree building and calculation, just click go. The very same way it was done before, and the information is going to appear on the right. The only real difference is that the information is going to appear way less often because preflop trees are humongous and it takes a lot of time to calculate, right? So we are going to test that, but on something way smaller. So I prepared different configuration here, which is still from the button, and then there's a big blind who only 3-bet on and fold. Because in this preflop solver you can choose your betting structure, so you don't have to include a call. Like normally, you can make him 3-bet and fold or fold. So this tree here have only like 2 exits. You see, I already filled that in as well. And again, this is 6 max, but this time OOP players on the big blind, this is 10. IP players on the bottom, so they don't pay any blind, and there's 5 from small blind who already folded, right? And also we can see that IP range is different. I made it raise to 25, so I input like standard still in range about 50%. And you can do that in this solver as well. And we are going to build this tree on very small subsets. So this is going to be like a toy example on 6, for example. We build that. You can see that this takes a while for all tree to unload, and then we need to build a new one. And this new one is very small, only 2 gigabytes because that's 6 flops. Yeah, so we have this tree here, and you can see that this is raised to 25 from the IP player, and then big blind, so OOP player has raised to 80 or fold available. And we go here, click go. We can see that the solver is working, and also that when you open the console, you can see that it's progressing very slowly. Like normally, this info is produced every 25 steps, and those steps are going slowly, right? Yeah, I'm letting it run for a while, and let's go back here. And what other configurations we have? We have this 7BB tree, which Will Tipton solved for his book. I can verify that this is this tree exactly, like 50% sizing after the flop everywhere. I removed some OOP bets in lines where they are not going to be used anyway, so where IP is aggressor. Yeah, and here we have traditional heads-up structure. So IP is in a small blind, OOP player is in the big blind, and the stacks are 70, right? 7 blinds. So yeah. Okay, how is our solver going? That's 9 steps in. Yeah, this is not practical, unfortunately, to solve it during the video, so I'm going to stop it now and calculate results. Again, for that you need to wait a while. And on big trees, it may take even several minutes. On this one, it's going to appear in a while when it stops. Yes. So we have those results here. You can notice an interesting thing which we hadn't seen before. That EV of OOP player and IP player doesn't add up to 0. It adds up to 5. And the reason for that is that we have used this configuration, and it had 5 in the pot already from the small blind, right? So both players who are remaining, they split this $5 between themselves. So that's why EVs add up to 5, right? Because there was dead money in the pot. And we can browse that tree, right? You can do strategy EV. Yeah, this is only race, right? But this is more interesting. And this is of course not solved yet because we only progressed like 9 or 10 steps in, and usually you need like 125 or 150 to get good approximation. If you can afford time, then I would suggest running it for like 200 steps even. So yeah, but we can see that this at least like moved in proper direction. Like we are 3-betting better hands, and we are folding bad hands, and then we are defending like almost everything, right? This is like very early stage, so yeah. Okay, so now I'm going to show you how to build a tree from scratch, right? So we are going to go IP player. Maybe we are going to build a 20 BB heads up spot. So IP player is going to put 5 in small blind. OOP player is going to put 10 as a big blind, and extra dead money in the pot is 0. The stacks are going to be 200, and the ranges are going to be full ranges, right? Because that's the start of the game. Yeah, create new tree, and we are in the root node. So here, maybe, yeah, so I will put array size of 20, so a min arrays. Then there will be a limp and a fold, right? And after min raise, an option is going to be a shove, a call, and a fold. And after shove, we need call and fold as well. After limp is going to ISO raise to 30, or check behind, or fold. And after that, we have check raise all in, call and fold. And here we also need call and fold, right? And that's the full tree, and it's showing us that there are 3 preflop exits. They are in green, and in yellow there is a node which we just selected, right? But the preflop exits are in green, so we need to fill that data in here. So first there's a min raise and the call. So we are going to use like standard sizings, maybe 40%, 50%, and 75 on the river. So that would be mainly all in by this point. And the raises like 2.5, 3x, 3x copy. And here we don't need a donk, but because big blind is checking 100% almost anyway. And so that should be enough. I also like to put cap 3 because that simplifies the tree a lot, and it doesn't change evens much. And then we go to another exit. This is a limp raise call. So here like 35, 45, 75. Raise sizes are going to be 2.x, 3x, 3x. Copy that. We need OOP bet on the flop here because OOP player is an aggressor, so it's important to include. And the cap 3 again. And then here this is call, and here we can choose like traditional bet sizes because the stacks are relatively big here. Yeah, like this. Cap 3 again to simplify. Yeah, and that's the call tree, and I'm going to build that on 10 flops maybe. A building on 10 is nice because that's easy to multiply, the RAM amount taken, and then you can estimate how big it's going to be. Yeah, this one, and build tree. So let's see. Yeah, on 10 flops it took 7 gigabytes. So that suggests to me that it's safe to build like 35, maybe even 40 could fit. Yeah, we can try that. I hope the video won't crash on us. Like if you go to here and choose like 40. Yeah, I don't want that. I don't want to try that on video. I will try 38, right? And we build. So first it needs to unload the old tree and build a new one. So yeah. And I recommend you get used to this task manager thing and looking at memory because yeah, usually when you are running the solver during the night, you can use all your RAM here. But once you start like Firefox, Chrome, and open a lot of tabs, then stuff is going to take memory and you will have less available. So you need to develop some feel for that, how much you can use on your system. And that's 27 gigabytes. Yeah. No, it's not ready yet. Probably the viewer asked for EV or something. Okay. So Yeah, probably we need to disable that because the viewer asked for EV on this big tree, and this big tree is big. So yeah, you can browse it now and see that this is quite, it's what we wanted. Raise, show, call, and here we can verify as well. And after call we have raised to 30 and check, right? Go to 30, there's a combination but available. Yeah, so this is a tree we wanted, right? Okay, so that's for tree building, and then again you go here and click go and wait for several hours at least. So after we solved a tree, and I mean we build it, we solve it. You can save the configuration here, and then you can save the whole tree. Traditionally, going to save, you can save the whole tree, but this one is going to be very very big because it's going to take as much on disk that is taking in RAM, so almost 30 gigabytes, and that's something you don't want. So what I recommend is going to forget turns and save. So this is going to be a small save. It's only going to include preflop strategies and then flop data as well. But when you go to the turn, it's going to need to recalculate for you. So that's this. I'm going to show you some sample saves. Saves, preflop saves here. So I have some preflop saves prepared, and some of them are, big ones, like several gigabytes. And to compare the size, we see that the big save on 60 flops, which I did on this computer. So I ran this Tipton 7BB tree on 60 flops, and I make the full save. It took 25 gigabytes. But when I forget turns and only save flops and preflop, it's going to be 40 megabytes, right? So this is not a big file. And it actually loads instantly. The reason it takes time now is it needs to unload this big tree we have just built, so that's taking time. But loading itself is instant. We are going to test that in a minute. As you can see in this preflop solver, everything is slower, and often like 10 or 20 times slower than before. And yeah, the reason again is that those trees are very big, and like you need to spend significant time making sure everything is built exactly as you want before you commit to running this for several hours, because there is nothing more frustrating than running a tree you didn't really want it to run and like wasting several hours on that. Yeah, it's unloading, and then after that it's saving this instant, right? Just here. Maybe I'll do it again when I have like small saves, for example here. It's instant, and then we load this one. Yeah, and then after you load a solution, you can browse it. Like this is the 7BB solution. If you are familiar with, with what Will Tipton did, for example, or some other guys solved it on all flops, then you can compare how good the solution is. So, yeah, it's very similar. You can go here like strategy, and EV. You can try going to flop as well, right? And we have this thing here that min raise is never used in this game as well, right? Yeah, I'm going to show you one more. There is 100 BB which we solved. 100 BB, I think this is here. So this was solved on 75 flops. Obviously, that was a big machine, and our options were to raise. That was the heads-up spot, right? And the options were to raise to 30 or call. So make limp, and surprisingly, the limp is used a lot, like 35% for IP player. So that's a big change from allowing only raise to 30. And then we can see that this is 3-bet in range. It looks quite standard. Yeah, after 3-bet we fold 45%, and we defend, yeah, usual hands here in green, right? We 4-bet Yeah, this is one thing which might be surprising to many people, that ace queen is not a 4-bet, or even if it is, it's only rarely so. And we don't shove ace queen, right? We also don't shove aces, which is a recurring theme in those solutions, that aces are a slow play against 4-bet, and you shove ace king, king king, queen queen, jack jack. That's usual, and there are some bluffs here as well. Yeah, so this is a big solution. But to get a solution on 75 flops, you will need to run it on cloud or use our cloud service, which is going to be announced. Yeah. Okay, so that was for an example. As you can see, there are some prepared ones as well. So important steps are you build a tree, you verify that preflop exits are filled correctly, then you build stuff or on a very small subset like 10 flops to see how much memory it takes in Task Manager, and then you try bigger subsets and see what can fit in your RAM. You can also go to here and type show memory. You will see how much memory is available and how much is how much is available and how much you have overall. So that can be useful information. Okay, so a few more details. What you need to do to use it comfortably is hide line frequency information, because that doesn't work for preflop trees, and even if it did, it would be very slow. So check that. Another thing is that when the solver is solving, like if we build this, for example, on 5 trees, build. Then when it's solving, you can't ask for EV because that's going to be an error. But you can look at strategy when it's solving, right? You can look at that. You can look at range as well, but just not strategy with EV. And also, you shouldn't go to the river when it's solving. I would prefer you are not going on the flop either, because that's not very well tested and it could cause some problems. So it's the best to stick to just looking at pre-flop. When it's solving, then click stop, wait for it to stop, and then you can browse the whole tree. And yeah, and also if you want to have this forget turns, so very small size, then you need to go to tools configuration and enable forgetting turns. Okay, so that's it. I hope you have fun with that, and I think this solver is very usable, having 32 gigabytes of RAM. But to use it really comfortably for bigger trees, like for example, we have heads up, sit and go here with a limp and a min raise and a small 3-bet. Those are 4 exits, right? So to build something like that on decent amount of flops, you would really want to have 64 gigabytes of RAM. And another option is you can run it on cloud instances. You can run it on dedicated server, which you can rent. It's going to work there. And we are going to announce our cloud service as well. That should be cheaper for you than running it yourself on something like Amazon. And of course, it's not going to be. I mean, you don't have to use it. That's like only additional option for you to make it more convenient. You can run it on your server or whatever you rent. So there will be no limitation at all. Okay, so I hope that is useful, and you are able to build some trees yourself and play around with the solver. As you can see, like everything here is like very early version, so any feedback is welcome. We are going to work on this like a lot in coming days and weeks. We wanted to release fast, and because that's already usable, it's already like very powerful solver, but a lot of details are going to pop out, and yeah, we are going to fix them. So that's it for now, and I hope you have fun.